Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Harith bin Abdullah. Registration number or ID number MA19202. Today I want to present about experiment title about the Bernoulli principle. We are from section 2, group 3. Okay, for the abstract, in this report, by using the Bernoulli equation, we will analyze how the interior diameter of a venturi tube effect, the total pressure head, static head, and dynamic head. Bernoulli principle links a fluid pressure to its elevation and speed. In water, air, or any other fluid with a low viscosity, Bernoulli equation can be used to approximate these values. Bernoulli theorem for a flow streamline is based on three assumptions: constant flow, incompressible fluid, and no fluid friction loss. This experiment will look into the validity of Bernoulli equation to enable observation and conservation. A graph of data point will be generated by Microsoft Excel. For the background, according to the Bernoulli principle, an increase in a fluid speed is accompanied by a decrease in static pressure or a decrease in the fluid potential energy. Although Bernoulli established that the pressure decrease as flow speed increase, the sum of all kinds of energy in a fluid along a streamline is the same at the point on that streamline in the constant flow. This necessitates that the total amount of kinetic potential and internal energy remains constant. Bernoulli principle relevance can now be described as total pressure is constant along a streamline. The total pressure on each streamline is the same if the flow is irrotational, and Bernoulli principle can be described as total pressure is constant everywhere throughout the fluid flow. The Bernoulli equation can be stated as rho P over rho G plus V power of 2 divided 2G plus Z equal to constant. For the problem statement, the problem that we see about this experiment, which is how to handle by using the principle of Bernoulli theorem to derive equation by applying the conservation of linear momentum principle. The second one is how the way that the internal diameter of venturi effect to the static head, velocity pressure, and dynamic head during the experiment going on. For the objective, to determine the principle of Bernoulli equation in incompressible liquid. The second one is to understand the concept of static head and dynamic head in liquid flow. And lastly, to observe the method of measurement, calculation, and evaluation during experiment was carried out. For the scope for this experiment is a series of manometers stepped into the venturi to measure the pressure head, and a hypodermic probe that may be navigated along the center of the test section to measure the total head make up the Bernoulli test apparatus. Static and total head are measured at all 6 points within the venturi at any given flow rate. The volumetric tank is then used to determine the flow rate. The fluid velocity at each of the 6 points within the venturi can be determined using both the volumetric tank and the dynamic head. Thank you. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf Iqbal bin Arwin, metric number MA19126. And I will present the Chapter 2 Literature Review and Chapter 3 Method and Procedure. First, I will talk about the Bernoulli's principal theorem. Bernoulli's theorem states that in an ideal incompressible fluid, when the flow is steady and continuous, the sum of the pressure, velocity, and elevation heads along a streamline is constant during steady flow when the compressibility and frictional effect are negligible. There are some limitations that has been imposed on using the Bernoulli's equation. The limitations are: first, steady flow; second, frictionless flow; third, no shaft work. That means not applicable in a flow section that involves a pump, turbine, fan, or any other machine or impeller, since such device destroys streamline and carry out energy interaction with the fluid particles. When this device exists, the energy equation should be used instead. The fourth one is incompressible flow. That means the density is taken constant in the derivation of the Bernoulli equation. The flow is incompressible for liquids and also by gases at Mach number less than 0.3. The fifth one is no heat transfer, means the density of a gas is inversely proportional to temperature, and thus the Bernoulli equation should not be used for flow sections that involve significant temperature change, such as heating or cooling sections. The last one is flow along a streamline, that means the Bernoulli equation is only applicable along a streamline. Next, the method and procedure of the experiment. The first one is experiment apparatus. We got pipette tube, measuring tank, pipe valve, manometer valve, motor pump, multi-tube manometer, and venturi tube. And the procedure are as follows. First, the vent valve will turn open. Second step, the pump is turned on and the volume rate is adjusted until 5 liters by using the control valve. Third one, the stilling valve was plugged into the hole before starting the experiment. The next step, the flow rate were measured by using the volumetric tank, and the total of pressure is also measured by using the pipette tube measurement, which is located on the right side of the apparatus. Lastly, the static head was measured through the multi-tube manometer, and the flow rate, total pressure, and the static head were measured at all 6 points within the venturi. That's all from me. I will pass to the next presenter. Thank you.
Hello, I am Wan Abraham bin Wan Muhammad Sofi. My metric ID is MA19109. I'm going to talk about chapter 4, that is result and discussion. Firstly, I'm going to talk about the total heat dynamic measured and calculated against points graph. The total heat dynamic measured and calculated against point are shown against the point of venturimeter in the graph above. The fluid's flow rate Q is a constant of 0.00263 meter cube per second. Next, velocity measured and calculated against point graph. The graph of velocity against venturimeter's point shows that velocity measured and calculated against venturimeter points. Both data sets have a nearly identical pattern. The measured velocity of a moving fluid is based on the head, but the estimated velocity is based on the cross-sectional area of the pipe and the flow rate, due to the viscosity of the fluid at the pipe surface, which cause friction. There is head loss in the pipe. As the result, the predicted velocity is slightly lower than the measured velocity. And lastly, the pressure dynamic measured and calculated against point. The dynamic pressure is shown against the point of the venturimeter in the graph above. The dynamic pressure of a flowing fluid rises with its velocity. Cross-sectional area decreases as the pattern progresses from point 1 to 3, increasing the velocity of the moving fluid and consequently the dynamic pressure. We may infer that this experiment was successful based on the data collected, as it was demonstrated that the flow rate manipulates the dynamic pressure. I pass to the next presenter. Hello, my name is Muhammad Nizam Yamanasi, MA19134. So I will talk about discussion. The goal of this experiment is to test if Bernoulli equation hold true in temporary dark with a constant flow of water due to the volume traveling through the pipe in a constant time. There must be a drop in pressure. The lower the pressure, the faster the rate of flow, and the higher the pressure, the slower the rate of flow, according to Bernoulli principle. The equation is determined by integrating the Euler's equation along the streamline for a constant density. The Bernoulli constant varies from one streamline to the next. By an incompressible flow, it remains constant. It has shown to be a highly effective weak mechanic. Instrument, despite its simplicity, Bernoulli equations state the sum of kinetic energy, the pressure energy, and the potential energy per unit weight of the fluid at any point remain constant. If the flow is steady, rotational, and finishless, and the fluid used is compressible. However, it is based on the premise that no external source adds or subtract energy. The equation is used to solve a fixed jet trajectory, flow under a gate, and flow over a where are all examples of fluid flow, difficulty, pump, and turbine flow, and so on. The system is self-contained, a supply tank and a flow channel make up the equipment. The channel process is compressed for a certain length before gradually expanding the remainder. Thank you.
Assalamualaikum. My name is Muhammad Hazarul bin Muhammad Nawawi. Now I would like to present about chapter 5, conclusion. In fluid dynamics, Bernoulli principle states that an increase in the speed of fluid occurs simultaneously with a decrease in static pressure or decrease in the fluid potential energy. So, in this experiment, with the measurement of the static head, there is a relationship between the static head and the dynamic head based on the Bernoulli equation. As a consequence, the experiment aims are justified. There are a few things to keep in mind when we collecting the data from this experiment to prevent making mistake and to get a better data.